We are now going to take a strong look at normal curves or bell-shaped curves. Now, we've already learned some things about the empirical rule, but let's take a look at another example of using the empirical rule. I've got the picture of a normal curve right here, and let's suppose that the mean in this particular curve is 100 and the standard deviation is 5. Okay, so with that in mind, we can label things on this normal curve. The mean always falls in the exact center of the normal curve. So I'm going to label the center point here 100, and I apologize, I don't draw really well with my with just my mouse. All right, so the mean is always right here, smack in the center where the highest point of the normal curve is. Now we have a standard deviation of 5. So these points that are indicated on either side of the 100 are one standard deviation away. So if I add a standard deviation to the 100, that means this point represents 105. And if I subtract a standard deviation from 100, this one represents 95, since our standard deviation is 5. Now I can do the same thing now to get these next little points right here, which are 2 standard deviations away. So if I add another 5 to 105, 2 standard deviations away over here is 110. And if I subtract 5 from the 95, 2 standard deviations away over here is 90. And then finally, if I want to do 3 standard deviations away, I can add 115, or add 5 to get 115, and over here subtract 5 to get 85. Now let's remember that our empirical rule says that 68% of the data falls within 1 standard deviation of the mean. So in this case, our 68% is between 95 and 105. So in this particular instance, 68% of the data will fall between 95 and 105. Remember, the empirical rule also says that 95% of the data will fall within 2 standard deviations of the mean. So in this instance, 95% of the data will fall between 90 and 110. And then finally, the empirical rule says that 99.7% of the data will fall between 3 standard deviations of the mean. So that will be between 85 and 115. Now, another thing we need to recognize about normal distributions is that they can take all kinds of shapes. And I mean by all kinds of shapes that they could be flat or tall, or they could be kind of in between like this one here. So notice that all 3 of these are normal distributions. They all have the same mean. Their mean is located at the highest value on the bell itself. All right, so in this case, they're all located in the same spot. However, in each of these 3 instances, they have different standard deviations. The curve that is the most spread apart has a larger standard deviation. Remember, standard deviation represents spread, so the more spread apart the curve is, the larger its standard deviation is. On the other hand, this one that's really tall and skinny has the smallest standard deviation because it is narrower and has less variation. The one that's in between has a standard deviation that's between the other 2 curves. Now, what we're going to be doing soon is, because we can get so many different normal distributions, they all have these different shapes, we need to be able to standardize them. So we'll concentrate in the next video on how we go about standardizing them with the z-score.